Hey guys, I hope I'm audible. Hope I'm audible. Yep, just checking the Twitch one as well. Is this the old one? Okay. Yeah, so the agenda of today is to finish up the persistence that we have started yesterday, which was actually we were near to making the wall work. I'll just show that what we were having yesterday. Yeah. So we were having this almost working it, but we could have made this simpler actually. We actually don't need the wall to be working, so this is only needed for error recovery. But still, we are going with it because we don't know what might happen. So we're just going with it. So if I run this now, I'm not able to get that value here. So that was the problem yesterday. And also this has to be like for multiple keys, not just for the single key. So we can't just hard code it here. We have to run it in a loop. So let's open Postman and see. Okay. So if I do one, I'm not getting to get that. Yeah, it's because the problem is going to be this. What could we do here? So first thing is we have to make this run for until the end of the file, or until, let's say, the counter, or let's say pointer is at 0, and while there's no while in Go, so ptr is less than len of that, you're going to run that, and we're going to put this entire thing inside this. Yeah, so for each one we're going to say ptr is, we are going to add how much we're going to add. We actually have to do that here. So if we say we are going to add 1 here, actually 2, key size the second one. Again we're going to add the key size here. I'm actually not sure what exactly is happening here. Let me see. Do we have the comments? Okay. I guess I could stop this. Okay. So am I live or not? It's really hard because I've been not live since so much time. So am I live? Just mute it. So what should I do now? Yeah, I think it's good now. Yeah. Okay. So the hard part is to keep tracking this. Okay, let's do one thing. Let's undo everything. Okay. So we're reading from this. For each byte we are going to see, and we are going to check until you have to see until what this is like we have to track. So this should be okay, but we need to keep track of this. So it's how much it's basically. So it's, let's say, 2 plus what's the key size, val size plus it's not byte, right? Okay, so this should be int. So that's okay. So we have int of key size, we have the key size, we have the value size. So plus 2, I think this should be 4, isn't it? Let's just try that. Okay, we got it 2 times. Okay, let's remove the equals. We don't have the equals. So let's just print what the value of ptr underline is going to look like. PTR is 36. Okay. So we are doing something wrong somewhere. Okay, I think to keep it much simpler, let's do one thing. Let's get rid of this. What's error? Yeah. Let's get rid of this. So the problem, so now we don't have the problem because we don't have anything to store. We are not reading from anything. But when we, let's delete this val file as well. But when we are writing to the, what is it? When we are writing to the file, I mean we are still writing to the file here, to the whatever we are just recording it in order to play it back when we restart. But we're not able to play that back. Maybe we can make this much easier, right? We don't need it to be in such a way. Okay. So what if we separate everything with a space? That should be good, right? So so let's say, so what if I do this? Can I do this? Okay. I could do this, right? So one is type put, and next is the length of R key. I could convert that. Can I? Okay. I could convert that to this and put it like this. Yeah, that's true. So what I want to do is I want to do something like one space, the length of the size of the key, let's say it's 3. Next is the key itself, ABC, and the value itself, let's say like this, right? The thing is we don't need this, right? So we don't need this. So we'll just append. Do we need to write it in form of byte? Why can't we write it as a string? Okay? So instead of writing, I can write string, right? Yeah, I could do write string. So here data is going to be type string. Wow, nice. So um, we're going to say data. So now it might be a bit easier because let's hard code this first. Space, and then what do you say? It's key, right? Again, it's a space, and then it's a value. Why did I even make this complicated? I have to make this to a string. But the problem is here converting to string is a big headache because it can be anything. So that's a problem. Can I do interface to string? Okay, you could do that as well. So I could do, it's just a small trick, right? You can just do r dot value here. That could work as well. So now we have the data and we will write string of the data. Yeah, so this we are doing, and when so in the init function we're going to again open. Okay, let's do undo. I want to go here and delete it. So we're going to read the file. So if error is not null, then we are going to say let me check let me have this open as well. Yeah, Tibin, this is live. So I was actually going to do live on this Twitch, but I then figured out a way to do live both on YouTube and Twitch. So yeah, so that's the delay actually. It was to start around 10, but I was around figuring out how to make it work. So that's the problem. Yeah, so we are reading from val. So okay, another thing is that we need to write in lines. So if I go here, right, let's just remove everything. Can't even. Yeah, so if we write a string here, will it write in a new line? So we need to write a, let's say, new line. I'm not sure if that's actually going to create a new line, but let's see. Let's actually test this first. But there's some error here. Okay, I'll just comment this for now. Okay. Oops. So I'll go here and create a key, and I think it's created. Yeah, we are getting this. So if you see, we have the key and the value. If I go back and update this to 3 and 300, yeah, it's actually a new line, so that should be fine. So we can just read these lines and populate our data structure, what we have here, which is a KV. So to someone just coming in, what we are just doing is that we have a key value store, we have this DB here, and the problem with in-memory DB is that it just disappears when you restart the server, right? Or when the program just ends. If you just kill it, the data just goes away. So we are just fixing that problem. So we are writing all the key and value to a file here, and whenever we restart the server like this, we just read from this file and populate whatever db here. So right now we are just populating it. We haven't yet, but that's the goal for today. Sorry. Yeah, so this thing is populating correctly, so we can read in lines. So that's what we're going to do. We are going to read file, but read file gives us in bytes, right? Is there any read? How do we read the entire file in lines? Okay. There are multiple ways to do this. That's the problem. I'm not sure which one to do exactly. You know what? I'm just going to copy this. I'll just go here and see. I'll just paste it entirely. So we are just opening that. I'll just put the error message here. Yeah, let it be file. File path is just the file name, which is val. And yeah, so we are getting the line here, right? So let's print the line. Yeah. So if I restart this, it's because we haven't called this function. So whenever we start this, we need to call this function. So we have two routes actually, one to get and one to post. So yeah, we are getting this. So one is actually not needed because we're just putting that in order to denote what kind of operation we are doing. In this case, it's a put, but we can even store get or delete as well. Although delete doesn't make sense, but that's fine. Yeah, so we are printing the line here, right? So instead of printing, we just want to populate the kv here. So yeah, so what we're going to do is we are going to say kv of okay, we have to actually do some string interpretation before that. I guess we can split this, right? We're going to split this in the space, and then we get those three in parts, right? So basically what I'm going to do is we're going to split at the string, so this each comes as a separate string. So that's the thing. So we can actually pick this up. So this returns an array of strings. It's actually a slice, but what do we call this? Keys, key and value, let's say. Right, so we're gonna see d.kv of key and value of 1 is equals to key and value of 2. Before that, we also want to say if the length of key and value is not equals to 3. It must be exactly 3. If it's not 3, then there's something wrong with the file. It might be corrupted or something, so we will just skip that. Error reading val. So we'll just do that. So yeah, let's try this now. Are we still printing it? Oh yeah, we don't want to print that. Okay, so if I go directly without pasting this, without creating that key, if I just go and get this key, I should be able to get it. Yeah, we get it. But if you observed the problem is that this is in integer and what we're getting is in string. So the types are not being mapped, because if you see here, so to make it to, let's actually confirm that if it's working again. So if I hit this, yeah, I'm getting, if I hit 1, no, 2, yeah, wait, 200. Yeah, so if you see this, right, we don't have any type mapping anywhere. We don't know what type we're using. We're just using any here, and then inside the roots as well. We're not verifying for the types anyway. So we can do that. We have to do that because the types are important. You have to see that whatever type the value is, that's what being exactly returned back. Okay. So what we could do is we could, along with so in this wall we are writing one for the operation. So let's say the second one might be the type of the value. Let's say it might be 1 for string, 2 for int, 3 for float, or something like that. And then when we are parsing this, right, we can just convert the string into that data type. So that's the next plan. Tmux tab names. So where is it? So this is actually, I think, yeah, this is Ome TMX. So there is, yeah. So this is actually, I was using my manual TMX configuration, and then I came across this. So I'll just paste it if you want, because this has pretty much everything in it. So the important thing why I changed to TMX was Ome TMX was the pane resizing was much easier. Like I have this, I could resize however I want, right? And I can create, and I can again resize this again. So making this work with my custom configuration was a bit messy, so I just tried this, and it had the same key mapping, so it was very easy for me as well. So I just kept using that. So yeah, what were we thinking? Yeah, we need to add types, right? So here I think we can add a type of the value. So we are going to do a switch on type switch on the value. Let's say it's T and R. I don't think we'll need this variable. So I can just say it's a string, then do something. For now I'll break. And if it's int or int 32 or int 64, do something. And again if it's float 32 or float 64. I don't think there is float 32, right? There's only float 64. Oh, there's no float. And this is default for some default case. So if it's a string, we are going to just say it's 1. And if it's int, it's 2, it's float, it's 3. And if it's default, then let's say 4 for now, but we don't know what exactly it is. And when parsing this, so this will become 2, right? Because now this will become 2 and this is 3, because now we have the another element coming into the world. And so instead of having this hard-coded variable, we can just say wall line length, and we can just say here wall line length is an int and it's a 4. Okay. Yeah, so we are doing this, and so we are ignoring 0 and 1 for now. 0 we don't need, but 1 we do need, because this is going to be that one, depending on that. So switch line of 1, is it line? Okay, it's key and value. And if it's case 1, again we're going to do something. Similarly for case 2, case 3 and case 4. So if it's 1, I think we don't need to do anything because it's just a string. For now we could, so this is a string, Okay, 1 second. So this is an int and this is a float. So we have, what do we have? We have a string in our hand. So strings dot or string dot atoi, right? Converts to an int. Yeah. Or you could say parse int, right? So the int, this is going to be kn value of 1. Base is going to be 10. This is going to be 64-bit. So here the value, and I'm just ignoring the error for now. And let's say where v is an interface, or you can just say any. And let's do this. We'll use a v here. And similarly for float, I think we could say parse float. What is this? Is this 32? What is it? Okay, we don't have that. Bit size is 64. Right? We could even break it down, like we could say for float 32 we can add a separate number here. We could do anything, but for now I think this should be fine. Okay, so I think we have to delete this because the one we are going to add from now on will have another extra variable, so we don't want this old data to be here. So we delete and we will start the server. And we could go, yeah, we need to actually add the data for now. So if I go here, okay, this is 3. I get a type in int, but the have to check after restarting. Okay, we have an error reading the wall. What is it? Okay, we don't have the space here. I think we have to add the space. Okay, let's delete this, go back and again create that. Here it should work. Again, if we kill the server and we try to run this, why is it 3? Isn't it 300? What? Are we adding this? What exactly did we add? V, right? Okay, V is, we could say, so I'm not sure why we are getting 3 here, because it should actually be, so if you go here, we have 3 here. Why do we have 3? Because it's float. Okay, what is parse float? Okay. Okay. We have to, okay. Here we have to actually parse the actual value, not just the number. Yeah. So it's, what is it? 0, 1, 2, 3, right? 3 and 3. We get 300. The type is being sent. So if I try, let's say 4, and if I make it a string, 400, and if I try to get 4 here, it should be a string. So the types are matching now. So that's, the wall is actually working. I'll actually commit this. Let me commit it. Actually, I need to add a git ignore here. So yeah, make wall working. So do we need to add tests here? So because we don't have any test for now, but it's a good practice to add tests here. I think that should be good. Also, everything is in a single file. I don't like that as well. So we could what could we do? Yeah, let's actually move this to a new file. Main.go. I think we will keep it clean. Okay. So the problem is these routers. Okay, let's try doing that. So we have this. So this is actually function, right? So let's try. So let's try function put key. What? Yeah. So instead of this, okay, this should return an error as well. So instead of this, I'm going to say put key of. Why am I putting it? Okay. So how do we send that? I think it will automatically go in here. I'll just call that. What do you call this? So here we don't have DB, so we'll take that and put it there. I think everything is going to break for 1 second. Let me take this as well. We don't have the DB. Yeah, we have it here. So we can, yeah. So where do we initialize this? We need a struct here. Or yeah, we could just attach it to this DB here. Yeah, I could just say DB here. So when I'm creating this, right, I could just say db.putkey. And yeah, that should work. And another one is the get key. So we have the get key, and all of this goes inside that. Undefined f. Okay, we need the file here. So we don't want to open the file for each and every one. So we're going to add a file here, which is of val file. So this is os.file. Yeah, this should work. What error is it here? Yeah, we don't need this. Actually, we do need it because we could just ignore the value and take that here. So again, we just remove this and put db.getKey. Now it looks much cleaner, but I still don't like this paint here. But I think that's fine because it's just for one. Move this as well here. . 。  . 。 . 。 . 。 . . . . . . . . . . 。 . 。 . 。 . . . . . . . . . . . . . 。 . 。 . . 。 . . 。 . . 。 . 。 . 。 . 。 . 。 . This as well here. I think this should work. Let's check that. What? Why is the linter not working? Yeah, yesterday I think this was just throwing that thing. What do you mean? Okay, because we are running go run build up. I think we have to do go build with this. Yeah, that works. If I do this, yeah, we deleted that, so that works. Wait, what? Yeah, that works. Yeah, so we had the valve working, but I think that's not actual persistence because that's we're just putting the keys and values into a file and then just reading that. What we want is what actually, I mean, if you want to search for a file, right, or if you want to get a key from the DB, then I think it's much harder. But let me see. Where is Excalidraw? So actually Excalidraw is self-hosted, but we can host it. So someday I might host this. Yeah. So this is done, but the persistent layer is remaining. But I'm still thinking this is good, but how do we actually make use of this persistent layer? So even if we create this, right, how exactly it's going to help us? So that's one I'm thinking about. Let's see. So persistent, it comes with an E, right? So to make this persistent, we have B trees. So we have the package itself, B tree. So whatever data we are storing, we are going to store that hierarchically in a B tree on the disk. So this helps us when so I think we have this rows DB. So we have this key value store. This is actually key value store, so it's not a cache kind of thing. So if you see, it uses B tree, and even the one which I tried doing previously, which was this where is it? Nimbus DB. So even here I try to use the B tree in order to create B trees on disk. So we can do this here as well, but the problem is do we need that? And Redis does Redis use B tree? How Redis? Okay, it's storing that in a binary file. Yeah, it's similar to what we do, because whatever we do right now, it's a snapshot, right? But the snapshot we are doing, it's for each write we are going to create a snapshot, or we update the snapshot. But what does Redis do? Point in time. Yeah, it does, but it does in a regular intervals of time, I think. Okay, the user can also trigger that, and yeah, recovery like we do. I think this is just val, write ahead log, right? So append only file or write ahead log, I think everything is the same thing. But I think there are minor optimizations on top of this that it makes Redis insanely fast. But although now Redis is not open source, so I can't talk about that. We have Valkey, I guess, right now. Yeah, so this is a fork of Redis when they were open source, and then they have made it closed source, so it's now just Valkey. Yeah, here it is. You know what? Let's write some tests for this, because then we can think what to do. So some ideas which I was thinking is, I'll just rename this. One is snapshotting by command. So snapshotting by command means that right now which we are writing to the disk, right? We can force the user to make that command. Like he can just call an API or something so that we can write it to the disk. Although we are writing that when we write to the key value store right now, but we can optimize that. So that snapshotting is one thing. So adding tests, that's an important part. So I'll put it above this. And what else? Okay, we can disable persistence. We can add that. Let's add that actually. Persistence flag or no persistence flag. So AF and RDB are two different formats, right? Okay, RDB. Okay. RDB is good actually because it's a binary format, right? It's much optimized than whatever we are doing, because we have this new lines and spaces and all, so that is not exactly optimized. So we do have AOF as well. Oops. So I think fsync is yeah, so it's just flushing the in-memory data to the disk, right? So do we have fsync in Go? Yeah, we do have. But this is much different than what I thought. Yeah, so I would say first we can start adding tests and then we can see what we can do. So right now we have this db.go file. I have moved everything from main to db, but we still have a minor dependency here. Like we are doing this and then we are doing this, but I think that's fine. If you go here, we have couple of things we can test. One is the put key. So this should return whatever response we are expecting. And next is the get key, like the same thing we were doing by testing the postman thing, right? Even after disaster, it should do that. So in order to test this, do we need anything else? So yeah, before that, I just want to make this. These are hard coded. Don't want to make this hard coded. So I could say, what do we say? String type is 1. Type string makes sense because we are trying to say that this 1 is of type string, right? Int is 2 and we do have float is 3 and type unknown is 4 because we don't know. We can handle that, but I'm not sure. So this is type string, type int, okay. Type float and type unknown. So this basically makes reading easier. Like I don't need to see ones and twos here. I can just refer to the variables. Wait, put key, get key, right? Wait, did we just reverse it? Yeah, we renamed it bad. So this should be get key, right? That's okay. I'll just here I would say get key. This will be put key. Yeah. So we can test for this, but where did we? Yeah, when initializing here. So the advantages of writing this in variables instead of hard coding is, like, one of the advantages, we don't need this comment because this variable speaks for itself. So we could do that. Float and then type unknown, right? Yeah, I think this should be good. So in order to write a test, we can say db test.go. Actually forgot how to write a test. So in Go, so I have to see how do we do that. Where is that? Yeah. Okay, we start with the test and then we do that, right? So we say func test get key, or let's say initdb, and this will take, what is it, testing.t. So we can assert now, right? Yeah. So let's pull in db here, or main, because okay, so we create a db here. So let's say we create a db like this, right? And then we want to see the size of the kv is 0. Okay, let's say, actually what I'm thinking is this must be done within a function, so we must have a function for that. So let's say, where is the db? Wait, where is the db? I'll just bring it up. So we must have a func new db here, and this will return a pointer to the db. And this actually takes in few parameters, or does it? I don't think it needs a parameter, because everything we are just initializing simply. And we even let's take this, where is it, db.go, yeah, put it here. We can even say wall file name or path. So this makes it much cleaner, right? Because we were actually talking about this a bit back, and now instead of doing every do we even know to do that? So to initialize it, I think we must do it by ourselves, right? Because if we do this, and I can do dot init and then return, I think that should work. So if I comment everything and just say db is new db and just a path, this is much simpler, right? So I don't need any of this. Yeah, so that should be good. So here, even here, I can just renew db with the file vol test. So let's try asserting it. Assert db. Let's say it's not null. So what should I add now to get the assert? Okay. Let's go into the test again. It's still not as okay. Assert equal. No. It's this assert. So if I go test, okay, I think I have to do this /assert. How do we even add that? Did this even run the test? Yeah. So this works, and if you see here, we get this vol test here. So we can just start writing the test. We can just, so before even writing, I'll just put the skeleton here. I'll just want a put key first. And I also, and I need a get key. So we can even test for some edge cases. What edge cases do we have? Yeah, so we do have edge case, right? Because test db init after shutdown. So what this means is that whenever after restart, you could say, after restarting, the data must be persisted, right? So we can just try putting data first. Again, it's new db. So because we have created this db, right, we need I think of it, we need a db close call, because we have these files open here which we are opening, but we are not closing it anywhere. So we need the close call. So we can just put it below init. So I can just say close. So when you call the close, it just does the cleanup, like it does the d dot close. I think that's the only thing we need for now, because if you do that, you can just do defer db dot close here. That should close that. And also we can even remove the test files, right, or whatever the vol which was in that path. I'm just thinking, and just put it on a to do. Okay, so we have, in order to test this, we have a new db created. So let's try putting some values to it. How do we do that here? So we don't have any utility to do that, so which means we have to put this in a separate utility, right? So what we're going to do is, I'm going to say db star db. I'm just saying put here, and we're going to take key and value which is of type any. So we take the key value and put it in the db not db, the key value store. So we take this entire thing copy for now, and we can remove that. So the values type here, and its key, I think it can be string of key or key dot string. Okay, wait, key is a string, right? Or it could be any. So this is value, this is value again, this is key. So what we're doing now here is we are putting it to the KV, which is the hash map we have. That's the main thing we are doing. So what we return is an error, right? So we return nil here. Otherwise we just do log.fatalf. I think that is not needed. So what we can do is we can say okay or not okay. I think even that doesn't make sense because we are just exiting the entire server, the request. Wait, do we want to do that? Because log.fatal, I think it's not the appropriate thing to do. What we can do is we can just return the error and then handle it gracefully. So instead of this, I can do errors dot new, and then I can just do this. What is it? Is there any? How do you? Okay, I think we have to put this. So let's check up on you guys. Is there anything? Okay. I'll just return nil here. I think this can be updated. Yeah, so I think we'll return the error here and then handle that error there. So we're going to take this entire thing and delete it, and we can say okay is db.put r.key and r.value. If okay is not equals to nil, then we could again return an error here. Can we return? Yeah, this should return an error. This can be error here. Yeah, I think this is good, and we can even use that here. So I could do db.put, let's say key and then value, right? So we can assert that this error can equal to nil, right? And then we can also assert that the db.kv, the length of that should be 1. We could do that. Let me test this. Okay, it's expected 2. How is it 2? Because wait, how is it 2? If I do put, right? I'm just putting this one. Okay, I think okay, let's just equal the db.kv of key should be equal to no. Wait, what am I even doing? So the first thing is, why is the length? I think what I'm thinking is this has a default value, so that can be done. Even that I'm not sure. Yeah, it's 2. Why is it 2? So if I do this, no. Okay, I think, let's say when I get the key it should be equal, but we could do that. For now let's just put it as this this thing. So if after putting I need to do a get in order to verify it, let's do that. I think we can do that below. We could do the same thing and then say, okay, we have to separate the get first. Put we have did, but get is still bad. So again, get, I think it should be some key and I can return anything with an error. So I do this. So if it's not okay, then I'll return nil and then a new error. That error getting key, or else I'll just return the value and the error will be nil. And now I could do value and it should be error actually. So db.get key. Yeah, this should do. So now if I come back here and if I say db.get the key, I get the value and I get the error. I can assert this and I can assert that the value should be equal to the value. Let's test this. Yeah, it's passing. So this works. What else can we test? Yeah, so this is important one, wall, the persistence thing. So again so I think if someone writes, right? Okay, I think that's why the size is 2, because people are writing. I mean, we are writing but not cleaning this up, right? Yeah. So I think we need to do the close call. So we need to clean up that. How do we delete? Okay. Can we do this? This returns an error. So yeah, I think let's try. I think we can even try this now, which we tried earlier, which is len of db.kv, which should be 1. Let's try that now. It's still 2. Why is it 2? So the val file is not even there because we have deleted that after the test, right? We do have, we could try fsync, but no. Okay, let's try the restart thing after persistence. So to emulate this, we are going to first put this right? And then we somehow have to emulate the, yeah, let's do this. What we're going to do is we delete the db, right? Delete db. Can we do that? Okay, no, I just want to, can I do free? No. So what I want to do is I want to remove everything from this db, right? So okay, let's do this first. Let's equal, um, let's add more keys. Key 2, its value 2. Key 3 is value 3. And now let's equal the len of db.kv to be 3. It's not equaling, right? That's what we are saying. This is actually not. Let's actually add that here. Kv size, it's an int. So kv size in int, and here kv size is usually 0 when you're initializing. And whenever you put, where is a put? Yeah. So whenever you do this, kv size, we increment that, and then we unlock this, so that when we have the kv size here, yeah, kv size should be 1 here, it should be 3 here. Yeah, that works. Okay, so we have added this. Now what I'm going to do is I'm going to remove all the keys from db. So I'm going to delete from db key, db.kv. I'm going to delete key 1 and key 2 and key 3, and I'm again going to assert that the db size is going to be 0. Kv size, again kv size wouldn't be 0 because we're not deleting that exactly. So should we write a delete function? You know what, let's write a delete function but not actually have an API to use that. Yeah, we could do that. We could say, instead of get, we could say delete, and we would just give an error here. So OK will be db.kv of key. No, it's delete. Okay, it doesn't have anything, so let's just have that. So when we are doing this, we also, so this is, again we need to lock, I guess, because we do that and then unlock. db.kv size we are decrementing, but how do we know we actually deleted it? How do we know that? We need to have some kind, because the question here is the delete doesn't give me anything back. So how do I know that it's actually deleted or the key doesn't exist? Right? Is there any other way to delete? But how do we know that? I think we could check. So let's try one thing in the playground. So let's say we have a map, right? So we have a map here. Let's say var m string of string, and I say m of apple is equals to 100, and if I delete M apple, it should delete. At the same time, if I delete orange here, right? Wait, should I import anything? Okay, let's put it 100. Ah, come on. What? Okay. It doesn't throw any error, right? It just deletes, but it doesn't panic. So if I try to access something which it's not there, right? Like if I say how to check if a key is in the wait, let's try doing M of orange. So if this comes as nil, right, then it's much easier for us. But let's try that. Okay, it's just an empty string. So yeah, it just takes the default value of this, right? So if this is a string, it's an empty string. If it's an int, it might be 0. So for us, it's any. So what it might be? If we take any, right? What it might be? What is it? Is it nil? Yeah, so we get nil. So before deleting, I think we can check it like this. So if what do we say? db.kv of key is nil. Then we can just return, I guess. Or else we could do this. Yeah. So if I try to run the test now, actual 0. Yeah, instead of delete I have to do this, right? db.k, sorry, delete. Yeah, so that so even if I delete 4, right, it should fail because it doesn't decrement the count if the key doesn't exist. That should be correct, so it works. So now we have emulated the shutdown, and now what we're going to do is we're just going to say db.init, and then now say that the size should be whatever it is. I think 3. What? Okay. What, init doesn't update that? Okay, I think, okay, we should not do this. We have to do d.put whatever is here and this, because we do many operations in put. So what happened? What happened? So there is errors in 22. What's in 22? Okay, KV says expected is 12. Act 2 actually is 1. We expected 1, right? Wait. Okay, expected is 1. But actually is 2. Okay, why is it? Okay, expected must come first. So Yeah. Let's fix that first. Um, 0. Wait, why did it fail again? D dot put. Am I audible, right? Am I audible, right? Oops. Yeah. Actually, let's add a. I have to add a screen to the OBS. Like, there is intro, outro, but we need some break in between. I think I have to add that as well. I think we have to. Let's fix this. What's failing here? So KV size, it's saying it's 2. Actually, it's 2. Yeah. Why is it 2? Dot. If we close this, why is KV size 2? Because when we do put here, okay, we are doing an init there. Okay, but that still doesn't make sense because the val test should be empty when it starts here. Let's see. It's 0 here, and then we do init. So this is the problem. This should actually open this. I'll test. Did we even create that? Okay. We created that, and then we go in it. We try to open it. So it's not opening, right? It's blocking. No, what's the problem then? What? Okay, it's looping continuously. Why is it looping? Can't we just use the d dot val file pointer? Can't we just use that? Because bad file descriptor. What's the problem here? So the wait, why is it again? Because what we do here is we're not even closing it. You can just say defer here. So we create a new DB first. There, I think we do the init. Right. We're not closing it anywhere. Then why is it? Okay, let's keep it like this. And even I can just do this for now. Is it looping continuously? Oh, wait, what? Oh, wait. It's continuously writing to the file. Yeah, because we're putting it, so it's writing. But why? Ah, okay. Understood the problem. But still, it doesn't make sense. I think because we are putting it and at the same time we are doing the scan, it's like Tom and Jerry, like it's trying to catch up, but we're still writing it. I'm actually not sure what's the problem here. So we write this and return maybe. Okay, I'm actually not sure what exactly is happening because it was working good until now. I think until we did this, right? Because it goes into this and it tries to take a lock here. Is it why? Okay, so let's try that actually. So if I go here, no, if I comment this out and I say kv of key and value of 2 because let's try doing that. Yeah, I think that's the problem. I think that's a lock is a problem. So why is it even a problem? So that's the question here. I don't want this, so I must find some way to call this. Or let's try with the error. Let's try with the error. It's null. Wait, are we already having any keys unlocked? So if we go into this, okay, which lock is this? Because let's do this. So there are two locks now, R lock and lock. So lock is for writing, R lock is for reading. So here we are locking and unlocking, and in get, so this is put, right? In get we do R lock and we say R unlock, and again when deleting as well we do lock and unlock. That should be fine. Still I'm not sure it's working. So the problem we are facing now is that so when we are initializing the database, we are calling this put, then it's going into the infinite loop and not exiting this loop. But when we call it manually, right, it's working. So there's a problem, something with this function that's having a side effect, so that this is being continuously called. I don't know why exactly. Should we use, okay, let's do one thing. Let's go to the new tab, and what I'm going to do is I have this tool called Aider. Let's try that actually. Let's install the new version. So Aider is actually a tool. So I have bought few credits from Claude, and I can use the API key here in Aider to actually make Claude calls from my terminal itself, right? So the advantage of this is, so I could okay, let me show you. I'll just do this again. So when I do this, yeah. So when I do this, I start with saying that my model is going to be Sonnet, which is Claude Sonnet, and the API key is of Claude's, which is Anthropic, and I'm calling the env file, and no auto commits, which means that I don't want it to commit automatically. So after calling the command, this comes in. So what I can do is, so if I run this command in my directory. So now it doesn't scan all the files. I can manually add which file to scan, right? So I'll add, let's say this is db.go. I'll just add db.go. So there are different modes in this. So if I ask something now, it automatically updates the file here, but I don't want the Aider to do that. I just want to ask it something. So I'll just go into the ask mode. So the advantage of this is, you know, it exactly shows the number of tokens have been used. For example, let's say, yeah, so how much cost it's going to cost, how many remaining in the context window, maximum, so every information. So this is much helpful if you want to do everything. If you're a terminal person, I think this is very helpful. So this is one of my tools. I even have a blog on this. So okay, let's get to the problem now. So the problem is, yeah, so in line number 91, right, in line 91, the d.put is causing an infinite loop. Why is that? Okay, yeah, it writes. Yeah, this is what exactly said. Okay, so the problem is we are reading and writing from the same file, so that's the problem. As I said, the init is reading from wall test and we are writing to wall test. Again, it's reading and writing and it's going into an infinite loop there. So what can we do here? Any questions? No. Okay, again with Aider you can say these many tokens were sent and these many were received. So this is 280 tokens here. We sent 1300 tokens. Is it 1300? Yeah, I guess. So what can we do here? So the actual root solution to the problem will be to not to write to this file, right? This pointer. We have to write to some other file, but we actually writing to that file only. So it doesn't make sense. So what can we do? So initializing, I guess we need some other file. Wait, put doesn't. Okay. Put without. Okay, I think that's what this was suggesting, right? Put without val. So we don't want to actually write to the file here. We just want to update the hash map internally, right? Yeah, that makes sense. So yeah, we could do that. How can we do that? We could say put without val, right? So here I think we could say db.kv of key is value, and we do this when we are locking and then unlock afterwards. So with this again we can say kv size will be greater than 1. Only you must be sure to increase or decrease if kv of key is not null before setting this. So what we are doing is we are checking if key exists. If it doesn't exist, if it doesn't exist, then we increase the kv size. I think we should do this everywhere we increment this. Even here, I think I'll just copy this. Yeah. Okay, I think we have to update the put here to put without val. Okay, -3. What? It's expected 1. Let's go to the test actually. So which one is failing? It's 22. So this is failing. So kv is 1 is expected, but actually 0. Yeah, I think the one we updated, right? The put here. If the db, okay, it should be after this. Finally, we passed this. So everything is passing. So in this test, if you see, we added keys and then we tested the size. We deleted all the keys. Deleting this made the kv sizes equal 0, and then we did init. On doing init, we repopulated this from the file which we wrote, which is this, and then finally this might be called close because we are deferring it. That would clean up the entire wall test file. Awesome. I actually comment this because I'll just add a main as well. What else? Done. This is remaining. This is remaining. You can do this later as well. Create add test. So there's a confusion between this main and master branch. I don't know if I'm getting the main or the master when I'm cloning the branch. That's okay. Sorry, where is it? Okay, so should I update the profile picture or the display picture of my stream because it's the old one? Yeah, I've added this. Nice. So we have few to-dos as well. We could do that. Did we fix the val name? Okay, wait, let's try doing that once. So in db.go, right, we are using the where are we using that? Yeah, this one. Why can't we use this one directly? d.val file pointer. So it's giving me a bad file descriptor. So in line 64, why is it throwing bad file descriptor? Okay. Read write. Okay. So this is very helpful actually, right? Let's go back to the test. 55 is failing. Okay, why? It's actually 3. Okay, it's actually 0 is expected, but it's 3. Actually it's 3. So expected is 3, actually 0. Why is it 0? Why isn't this happening? Because but this worked, right? This was not working. Oh, it's really weird why these things happen. So if the key in it is nil, okay, let's just print over. Again, I can't do that, it will print everything. If I do init, it should be nil. Right, I think init is a problem. Yeah, of course init is a problem. So should we return it back to this? But this makes more sense. And we are not even creating any new pointers for this. I think this should be fine because we do this only once. But still I'm not really satisfied with this. Oh, should we be doing log fatal? That shouldn't be happening. You know what, let's create a new error which takes a string error and returns an error. Okay. return errors dot new printf e. So this should be e comma, wait, this is an error, right? Error and message, let's say. So this should be message and this should be dot error. So we will just return e of error reading val file pointer. This is nice little utility, right? And I'm going to use this everywhere. I'm going to use this error reading val. So init now returns right. So for this we do this. We're removing all the fatal blocks. E of error reading val. NewDB doesn't return an error. It should be error. So this would be nil and this dbn nil. So again we have to update it, yeah. I'm just fixing these small things. So for NewDB we are getting 2 arguments now. I'm just fixing that. And then do this. Yes, it's fixed. So where is log.fatal? Main. Okay, main as well. Now we can do log.fatal, right? We can do yeah, but still I think we haven't done that. The reusing the pointer I think we didn't do, but we can just do it to do here. Use d dot file pointer. Yeah, I think we can put this in error.go. So we do have a make file, I guess. We don't have a make file. We'll just have a make file, and we can say go build -o main. So this would, is that the command? Go build dash on make, yeah. And to run, we'll just say no. To test, we could say go test. Is that, can we do that? Go test. Yeah, I could do this. So now I can even do with make, like make build will build this, make run will run the server, make test will test it. Yeah, that's awesome. So we'll add these things as well. So I'll commit this. Update refactors. I'll just refactor. What are the refactors? So let's list it. So one is call E instead of log.fatal. The other one is add make file update test. I think that should be enough. Thanks, Siddharth. So I think we are at the end of the stream, because what we intended to do for this stream is pretty much done. Because so yesterday so the thing we are working on is in-memory DB, right? So the first part of that was to create an in-memory DB, which means just a hash map kind of thing. So every time you restart the server, everything goes away. So that's the first part, which we did yesterday. And we did get to some point of val yesterday, but some things were not working. So val in the sense, like when you restart the server, right, there is no persistence. So we write everything to a log file and then read from it. So I think today we did that, and as well as that we even wrote some tests as well. So I would say adding test is a great win for us, because I didn't actually plan on writing tests, but somehow we did today. There might be some more edge cases as well. I guess we could add that. If anyone is free to add it, you can add it as well. I don't know if I would continue this project, because for the next streams I would pick something new, because the scope of this is much more than what we think. So there is like we have the the persistence with us, like we have the val thing going on, but we don't have the real persistence, which is writing to disk and reading from disk. But we don't actually need that, because this is not a DB, right? This is just a cache kind of thing. This kind of in-memory DB clone. So they don't store things heavily. It's only needed when you're restarting that. You just should not lose the data that you have. That's the main point. I mean, there can be a lot of optimizations here and there, but I guess this should be fine. So anyone who is watching live, or anyone who will watch this in the future, please put it in the comment, like what should we work on next. And I will also create a YouTube post on that, like what we might work on, like any ideas for that, we can start working on that as well. I will just put this repo URL as well in the. So if anyone has any idea of what to do next, then I think I think it should be good. Hey Joe, yeah, I'm good. I think we are at the end of the stream. Thanks for joining. Yeah. So this is what we wanted to do today. We did everything that we could, and so I might exit now. It's around 12:30 here as well. So I'll just think about like what we can do. I'm just thinking of doing something more exciting and much more not so common things, right? So In memory, I think it's not common, but it's not like anyone is not doing it. There are people doing this. So I want to do something that will excite some people to start working on these things. At least for me, it must be something exciting. This is actually exciting because we got to work with persistence and all, so I like that. Okay, I think I will go now. I'll see you guys in the next stream, most probably tomorrow. I'll try to stream tomorrow as well. I will let you know in the YouTube post. So yeah, thank you for watching this. Anyone who streamed in, thank you. Thank you for following Joe Pio. Thank you. And thank you guys. Bye.